And we're live. Welcome to tonight's hangout. I'm joined here by Astronomy Live. He's kind of taken some time out to discuss some of the latest topics that we've been seeing flying around. And we're going to look at a few of these topics and sort of like... Oh, I'll just turn that music in the background. And to basically and get to the bottom of hearing sort of thing. So, are you there, Astronomy Live?
Yep, I'm here.
Right, okay. Well, welcome to the show, and thanks for giving us your time. I'd like to sort of hit on is what we've been seeing from Mr. Chris Potter. Now, recently he's come out with a couple of videos, you know, seems to have changed a lot, so I'll give him credit for that. He's starting to ask more questions and putting the, you know, in your asking, you know, for them to decide, and, you know, how he's portraying the information has changed. But it's still, a lot of the issues are a bit skeptical, and I'm just here just to clarify, you know, from your side and your perspective, what is true and what.
Yeah.
From a physicist paper about the sun jolting. So I was sort of going to ask you, obviously, if because I do believe you sort of predicted this, didn't you? So I'm going to ask you, what is actually the truth here? Did the sun jolt? If it did, what caused it? If it didn't, what did we see? So I'll hand it over to you.
Okay, so back on January 25th, we had images come in from SDO that looked a bit like this. This is from HelioViewer, looking at AIA 171, and oh my goodness, the sun, it's rotating, it's rotating, it's rotating, it's flipping. So I actually predicted this before it happened. This was back on January 25th, and right about the time it was going to start happening, I posted on Facebook on one of Daz the Cameraman's. We've got a private group on there, and I've got a new private Facebook profile, which unfortunately, because of my little incident with Nibiru channel and somebody sending text threats involving myself and a description of my girlfriend, I had to pull down my main Facebook channel because Facebook profile, because somebody had clearly seen my Facebook profile and was creeping out on my profile picture. Yeah, I'm here. Can you hear me? Is it not coming in?
It was. We just lost your audio there for a second. So can you just sort of go back to where you said you had to change your profile? That's when we lost audio.
Yeah, sorry about that. I don't know if my internet connection's being rough tonight, but yeah, so I had to change my Facebook profile. I had to take down my old profile, and now I have a much smaller profile that I don't go onto public Facebook groups anymore or anything like that. I was on Vortex, which is Daz the Cameraman's Facebook profile or Facebook group, where people can come and ask questions and we can discuss things like this. But unfortunately, I have the sneaky suspicion that when the Nibiru channel joined that group some months back, he saw my Facebook profile because I had been posting on that group, and he profile, and so he saw a picture of me with my girlfriend. And so even though my girlfriend has never been on my YouTube channel, he now had her description and put that description into a text threat that was sent anonymously to Jake and Mari. And so that was really, really creepy. And so I took down the Facebook profile. I took down my original Facebook profile altogether. And so created a new one. And I'm only joining private groups right now. I'm not joining any public groups like Vortex. But I did rejoin Daz the Cameraman's private group where we sort of have discussions about things like this. And I posted this comment back on January 25th, right when this was going to start, saying, anyone want to place bets on whether or not WSO, that's Steve Olson's channel, or another conspiracy theorist, C-Tier, will claim that this was an actual physical flip of the sun and or Earth, and then gave a link to the Twitter announcement where NASA Sun Earth on Twitter tweeted that the spacecraft SDO would be performing a roll that morning, and the result would be, of course, that the sun would look like it was flipping. This is just a calibration maneuver. In fact, let me pull up another link here. SDO is Go blog. The SDO is Go blog sort of routine maneuvers that they have to do. So January 2017, they actually did a number of maneuvers. They did a field of view calibration. That was on January 11th. And on January 4th, they performed a momentum management burn. I believe SDO, the SDO spacecraft, Solar Dynamics Observatory, for those who don't know, uses, I believe they probably use control moment gyroscopes to point the spacecraft and point the telescopes at the sun. And so control moment gyroscopes are devices that use spinning momentum to hold a spacecraft's orientation in space. So if you spin a wheel, you get a gyroscopic effect. And if you're in a spacecraft floating around in space, this actually produces an effect on how you're oriented due to the conservation of angular momentum. So they use these control moment gyroscopes to point the telescope and point the spacecraft. But when they reach a certain speed, they can't spin any faster. They can't, they actually do what they call, they saturate with momentum. So eventually you have to, it's sort of like, I don't know how to describe it exactly. It's a bit like unthreading something or gaining back the momentum capability of those gyroscopes. They have to use the thrusters to actively push the spacecraft so that those gyroscopes can spin back down, and then they can be used again. So the space station, the International Space Station, actually uses this kind of momentum management. So SDO uses it, and so on January 4th, they had to do a momentum management, what they call momentum management burn, where they desaturate the gyros using the thrusters, and they said Science Day is not available for 30 minutes of the burn. Okay, and then they also did this other calibration maneuver. Let's see, an HMI roll on January 25th. So that's what we're seeing here is the HMI roll at 1500 UTC, 10 a.m. Eastern Time. That's when they did this roll, and I think it ended up being around then. Yeah, I think it ended up being around 1500 or this here is at 1600 UT. So it took a while for it to occur. But yeah, for a period of time, the spacecraft was rolling. And depending on which wavelength you look at here, let's see, that's SDO 171. See, 131. Which one is it I was looking at? Here we go. So this is something else I noticed was pointed out in Chris Potter's video, where he noticed these straight lines here. And I don't know what he was claiming was actually going on here, but really what's happening here is if you click through these images, you'll notice that the SDO AIA 94 wavelength, the sun doesn't appear to roll at all, but the edge of the frame does. So what's going on here? Well, what happens? What would happen if you took the images and you tried to hold a constant orientation? Well, it's a square image. So you're going to get these edges here because this is the actual edge of the CCD. What's happening here is these images have been calibrated so that the sun holds a constant orientation so that north is always up on the ecliptic in these images. But because of that, because the spacecraft was actually physically rolling during these pictures, you have these edges here where the picture itself has now been rotated to fit the orientation of the ecliptic. And so I think he was pointing that out in one part of the video. I didn't see the whole thing, to be honest, but I did see parts of it, and I caught him pointing this sort of stuff out, and that's what's going on here. And then as it's rolling, it's actually in the middle of its roll here, and it's blurred the exposure of the sun, which is why it looks so blurry there. So
it's
yeah,
the actual picture and sort of frame that's rolling with as the camera's rolling.
Exactly. So that's what's going on here. And this was, they gave pretty good heads up that this was going to happen, not only on Twitter, but on their SDO is Go blog spot. They posted this back on January 11th. So, 14 days before it happened. You had 2 weeks of notice there, but I guess they didn't notice. So that's why I posted this prediction, because I totally saw this coming. When I saw that tweet hit my phone, I'm like, oh boy, I know what's going to happen now. Yeah, and sure enough, sure as
And lo and behold, yep.
Lo and behold, we have Chris Potter saying it flipped or whatever. It's just, It's predictable, but there you
Well,
go.
to be fair, it was meant to be from his physicist, so obviously it came from the physicist papers. But
Right. I don't, and I wish I knew who was behind that, but clearly, whoever they are, they're not a real physicist, and if they are, they're having a laugh because it's just
yeah, to me,
laughable.
it's like leading up the garden path in a sort of sense.
Yeah, exactly. And we'll see. I mean, we've got let's see, today's February 2nd, so we now have, I'm predicting, about 12 days until the start of the next SDO eclipse season. Let's see if Chris Potter's physicist comes up with a paper accurately predicting the circumstances of the start of that eclipse season. I'm going to be doing that in a video that I'm working on right now. I've been collecting data on the SDO spacecraft with my own telescope, and so just like before, where I predicted the end of the eclipse season successfully, I'll be predicting the start of the next SDO eclipse season successfully. And I can already tell you it's going to start earlier than it did last year. Dun, dun, dun. I can see it now. Videos posted by Chris Potter or posted by WSO saying, look, the eclipse season, it's getting earlier and earlier every year. Pretty soon, it'll be all year long. The sun will be gone.
Well, interesting. That'll be something to look out for on your channel. So I'm looking forward to that. And yeah, and it'll be interesting to see how these fear-mongering channels actually present that data. Right. Well, thank you very much for playing and airing the truth on that. So obviously, we all are fully aware of why this happened, and now we're going to look at, unfortunately, yet again, another one of our dear old Mr. Potter's videos. And this one, it's his collection of unfocused, what looks to be like unfocused stars or planets pictures. Now, I'll just bring one up, and I'll just quickly crop it for our screen share, and then I'll do a screen share now because I'm sure we don't want to listen to the speech. The picture's bad enough. Right, I'll just do a screen share now. Can you see this? Astronomy Live?
Yes, I can see, I can see that.
And obviously, as you can see, he shows a couple of images. As you can see, different coloured shapes, sizes. And I think we've all seen these before back in 2016. And I know we've sort of spoke about this. It has been already, explained, but yet again, it's 2017. To me, it looks real, trying to rehash old stuff. But we're going to ask you again, what are we actually seeing in these images? And can you explain why we're seeing them?
Yeah, so these are out of focus. Oh, I'm getting an echo there. Is my audio working okay? I guess it is.
Yeah,
okay.
it is. Yeah, sorry.
It's all right. So yeah, we're looking at out of focus stars there. And actually, that picture you're showing right there reminds me distinctly of some stuff I might have on my computer here. Let me pull this up, see if I can find a good example.
Okay, whilst you're looking at that, I'll stop sharing. So then, if you do have it, you can screen share yours.
Yeah, I got some stuff here. Okay, let me. I have to unfortunately have to convert this. It's going to take me a second because I've got to convert the photo. It's in the Canon RAW format, which my browser window's not going to know how to. Well, I guess I can just try here. Let me make sure. Sorry, hang on one second. I just have to make sure I'm not going to accidentally. Okay. I don't want to accidentally overshare, like, my full name or address. Or, yeah. I think this will work okay. Now, I just don't know if the only thing I don't know is if the screen share will share this application properly. Sometimes screen share doesn't like sharing certain applications. And it looks like it's not really going to like sharing this application. Okay, so I'm going to have to.
No, I'm just seeing you, unfortunately.
That's fine. Yeah, it'll take me a second. I'm going to have to.
So obviously, it's just getting the point across and explaining what we're actually seeing. Obviously, because we've all seen these, images before.
Yeah, I'm sure, but yeah, I just want to pull this into. Let me open up. I've got a program that'll convert this. That'll just take me a moment, but yeah, I do want to share this because it does show a pretty good example of the same kind of phenomenon and some out of focus stars that I recorded from South Africa, actually, on my South Africa safari trip. So I went down to South Africa and I didn't bring my full telescope with me. I just had sort of basic equipment. I had a small refractor, a camera tripod, and a Canon SLR, which I hooked up to do some shooting of the stars in South Africa from the southern hemisphere. And I did that actually a year ago this month, and had a good time, really good time. But I've got a whole library of photos, some of which are out of focus because I basically, I'm actually amazed I was able to get as many good shots as I did, because what I had was I had my little white refractor and my SLR camera was threaded up onto that. And I just had this chintzy sort of, it's not really the best refractor. So I just had sort of this chintzy focus knob that I was going in and out on. It's not like you can autofocus with this thing or anything. And the focuser itself is really floppy, so it takes a lot of adjustment to get it to do right. And so it took a lot of doing, but I managed to sort of through trial and error locate some objects to take pictures of with it, and got a pretty good picture. Well, not great, but got a picture of a nebula down there.
Oh, very nice.
So, but before I got to that nebula, so basically I had to focus on the stars and then just sort of move the telescope around by hand. No no automatic tracking or anything, to find the nebula, and then cranked up the ISO to max and took some very short exposures with no tracking and then stacked them. But of doing that, you end up with a lot of bad photos. So fortunately, in this case, that's actually what we're looking for. I don't tend to save the bad photos, so I usually don't have any on hand to show us as an example, actually, because I just tend to toss them out.
Start saving some from now on for these for these channels.
Yeah, exactly. I guess I should save my bad photos so I have examples to show. But I do, in this case, I actually do have the bad photos because I just saved everything from that trip. I didn't throw anything out. So that's why in this particular case I do have the photo. So let me see here. Is it going to? Where is it? Where is it? Where is it? Where is it? Okay. Oh, there it is. Okay. If I type here, I wanted it to sort by. Okay, so it'll just take a second. Let me reshare my screen now. I'm uploading it. It's kind of ridiculous. I'm having, because my photo viewing program will not share properly. So instead, I've converted it to JPEG, and now I'm uploading it to the interwebs, so we can zoom in and view it here.
Brilliant.
So yeah,
Well, thank you very much for doing this.
No problem. Yeah, I'm glad I thought of it. I just wish I'd thought of it sooner. So here we go. This is a slightly out of focus picture of the stars. And so if I zoom in, oh, look, we get all kinds of interesting colors on these things. Like here's some purple and surrounded sort of by this green color. And down here we got one that looks, I think, a lot like what you were just showing in his photo. If you blew this up even more, you know, and centered up on just this little one over here. So you get all these interesting colors and stuff. Here's another one that's kind of got that purple surrounded by green. This is mostly, I mean, the fact that it's out of focus, and also the fact that this is a pretty cheap lens here. This is an achromat lens, not anything fancy. And so you get chromatic aberration, plus edge of field effects, plus it's out of focus. So you have all these optical aberrations, and you end up with some very funky looking stars. And of course, you can tell they're stars because in this case, there's a bunch of them in the photo. And some of them have funny colors you wouldn't necessarily expect as stars. Like you wouldn't normally see a green star, but you have white balance issues with the camera. You have all these other, you know, optical effects that are mucking things up. And the only reason that it becomes obviously apparent that this is just a photo of stars is because there's so many of them. But if you took, you know, if you took just one star that was particularly bright, like none of these will really do, but maybe if you had a telescope, you took a really bright one like this guy right here, and you did the same thing, and you set the exposure fast enough that you didn't see all these dimmer stars, you only see this one, that's what you have. You have a single star that's out of focus with these optical effects showing up in that video, and that's all you're looking at here. So this is, you know, this is quite normal stuff.
And that's how you get
And I
like
think,
donut holes in them as well, I do believe.
what's
Because
that?
you can see some unfocused images that got like these like donut holes in them. Is that the same sort
Oh,
of
don't.
procedure of how they're created as well?
So in that case, you have some sort of folded optic system. So you have, like my Schmidt-Cassegrain will do that. And I've got a ton of photos and videos laying around of that happening with my Schmidt-Cassegrain telescope, because you have an optical obstruction in the middle of the telescope. So I've got a video right here that actually has an example of that. And I can pull that up real quick. So with the Schmidt-Cassegrain, you have a primary mirror and a secondary mirror. And let me turn off the audio on this. And that means you have this interesting donut shape. Oops, didn't mean to click on the ad. No, go away. I don't want the Valentine's sale. So let's see here. So here's what it looks like normally. Over here in the middle of the video, I make it look really weird. And actually what I'm doing is I'm just putting my hands in front of the telescope, and the heat from my hands is distorting the image. So heat waves cause all these interesting shapes to appear. If the shape is stationary, that's usually a sign of dust somewhere in the system, on the lens or on the mirror, or maybe even on the camera. So when you don't have the heat waves as much, you can see like stationary dots here and here and here. And they all kind of take on this sort of donut shape, because this is a reflection of the shape of the optics. So you have a primary mirror, which has a hole in the mirror, a hole in the middle of the mirror, and you have a secondary mirror out front. So the light bounces off the primary mirror in the back. It goes up to the front mirror and bounces off that and out the hole in the back. And when an object is out of focus, it takes on the shape of that primary mirror. So it looks like a donut. And then once you focus it, it all seems to close up, and before you know it, you have an image of a star. And so that's what the in-focus image looks like. So that's all that is. It's just an out-of-focus star.
As you were focusing it, you could also see how it was closing and still the different disfigurations it was showing as well.
Exactly. And you know, actually this is useful to amateur astronomers, because sometimes we'll deliberately do this not only to be able to focus our telescopes, but to actually be able to align the optics as well. So you can actually tell in this image my optics are not perfectly aligned. The center circle is not perfectly concentric with the outer donut shape. And so we'll align our optics by adjusting set screws on the secondary mirror to move it around in order to get this donut looking perfectly concentric. And so that's how you do that. And then once you get it roughly aligned, when it's way out of focus, you actually focus it in until it's closer in like this. And when the atmosphere is not so turbulent, you can actually see, you can still see a clear sign of the hole in the middle, and it'll become more and more sensitive to slight disruptions in the optical alignment. And so you focus it tighter and tighter, and you realign it and you realign it. You follow this process, and you know, the first time you do it, it takes you an hour, and by the time you get good at it, it takes you maybe 10 minutes at most. But that's how you do it. That's how you align the optics, and you can also do checks on how the optics are doing in other ways too. So yeah, that's really all that is. And here's some video from a refractor showing the same thing. And the other interesting thing about having a cheap refractor and a cheap lens is because of this chromatic aberration and everything. You get this, you get the purple in the middle, you get the green in the outside. But then if you go to the other side of focus, it actually turns purple. You sort of get this orange and purple effect. So this is because the achromat refractor is not bringing all the colors of light to the same focus point. Different colors of light, different wavelengths of light will be refracted at different amounts. And so green will focus at one point and red will focus at a different point. And as you adjust the focus, you'll see more of one color or the other, depending on what's in focus and what's out of focus. And so you either have a green fringe around the edge of the star, or you have a purple fringe around the edge of the star, depending on where you are in focus. So cheap lenses show this especially well. When you have more expensive lenses, they're designed to bring the focus point more and more together for all the different wavelengths. And they do this through using multiple lenses with different refractive indexes and all this fancy optical stuff, really fancy optical engineering to try to manipulate it so that all the points, all the wavelengths of light, at least in the visible spectrum, come to the same point of focus, which is why you pay incrementally more and more money for these telescopes. This telescope here that took these images, this is a cheap $150 telescope, but you could pay easily $1,000 for the same size telescope, 10 times as much, for better optics in order to bring all those colors to the same focus point. And most people who are putting up these YouTube videos aren't paying thousands of dollars for the equipment that's doing it. Or if they are, they're spending it all on the camera and not on the lens. So that's what's going on there.
Brilliant. Thank you very much for explaining that.
Yep.
Right. For the next topic, I'm going to ask you now about this asteroid that we've all been hearing about. Now, I did a video on this myself a fair few months back when it was first reported in the media. I'll just do a quick screen share so you get to see it. And it was when the tabloids were hitting hard on it, talking about these two asteroids that was going to collide into Earth. And they were giving it all the fancy headlines. And can you see my screen, yeah?
Let's see.
Yeah. Can you see my screen?
Yep, I see it.
And they're talking about 2016 WF9 and then obviously 2017 BS32. Now, if you recall, I think this was dated a few months back. Anyway, it's when it first all started hitting the scene, and a lot of tabloids got on it, and they portrayed that it was going to obviously impact Earth. But then if you read further down, it did actually say, at the bottom of the article, after it's done its clickbait and everything, that there was going to miss us by, I think it was 32 or 35 million miles or something like that. Yeah. But the recent turn of events now have come out saying that this Russian astronomer now is backing this and saying that NASA and all the space agencies have misread the orbit and obviously, etc. to it, and that there is a possibility that this could impact Earth. So my question to you is any of this true? And obviously,
no.
What do we do? So I'll hand it over to you.
Oh boy! Wow, I didn't see those headlines until you just showed. I mean, I knew people were talking about it and claiming it was going to hit Earth, but I didn't realize sort of the mainstream tabloids, if you will, were doing it as well. So this all
yes.
Oh God, that's horrible. That is horrible. So this all started on the Someone's Bones website, which is just absolute garbage. It's fake news, every single story, and it's all tries to tie it all into Nibiru in some way. They to give you a flavor of various fake stories they put out, back when the election here in the United States was going on, they were saying that if Trump won, he would announce Nibiru in his victory speech. Now, at the time, conventional thinking was that Trump was going to lose in a landslide to Hillary Clinton. So I think that they were probably banking on her winning, and they could say, well, he lost. He didn't get to announce it. Well, it didn't go in their favor. So he ended up winning, and of course, he didn't announce Nibiru in his victory speech. And so then the claim was, oh, well, he's going to announce it at the inauguration. Okay, sure. And then a day before the inauguration, they said, no, he had to change his mind. He's not doing it. So they put out these fake stories all the time. They even put one out that was kind of about me, or a screen name I was using online, and saying that I was a shill and all this stuff. With one of their so-called astronomers they were interviewing, he was saying this. Yeah, right. Well, this astronomer doesn't exist. It's a made-up name, and I contacted them and threatened them to take down the defamation, or I'd have to pursue legal options, and they took it down right away. So they I guess decided it wasn't such a smart idea to go after actual astronomers, or at least even amateur astronomers, and so all the names they use are fake. This doctor, I forget what the name they used was for this one. They always come up with these hilariously made up names. One time, I'm not kidding, it was Dr. Trowbridge, Trowbridge, which sounds suspiciously like Troll Bridge. Yeah, I wonder why. So if you go on to JPL website, you can see the orbital information for 2016 WF9. Now, this was an asteroid-like object that was discovered, However, its orbit is much more similar to that of a comet. If you look at the eccentricity, its eccentricity value is quite large. It's over 0.65, which is quite high. Usually for an asteroid, it's maybe a tenth at most of what this is. And you have decent semi-major axis here, 2.8 AU. And the closest it gets to Earth is a little bit closer than Earth gets to the Sun on average. And its distance, its minimum orbit intersect distance to Earth is 0.014 AU. Now that's great, but that doesn't mean that just because what they call the minimum orbit intersect distance is this value, that's not the same as the close approach distance. It's not how close it's actually going to get to Earth. So the close approach distance is listed in this table down here. So if you click close approach data, it'll take you to this table. It'll show you all the close approaches for the near future, within the next 100 to 200 years or so. No, excuse me. And I should point out this table generally only shows close approaches that are certain. If the orbit is highly uncertain, it's not necessarily going to show you much. In this case, the condition code is a 5. There's 111 days arc span of data on this thing now. But its condition code is still 5. That number will probably come down as more observations are collected. All newly discovered objects start off at a very high condition code, but again, that doesn't mean that an impact is possible. So if we look here at the close approach table, in February 25th, in the 25th of this month, it has a close approach with Earth. But that close approach distance is 0.34 astronomical units. Now, if you do the math on that and you convert it to kilometers, that is, what is that? That is 50 million kilometers, if I'm reading this right. 50 million and change. So really big distance there.
It's actually further out than what they forecasted it at first.
Yeah, it probably is. So if you look at now that's the nominal distance. You can also look at the minimum distance. So given the uncertainties of the orbit, the minimum distance is this number here. So you can just do a quick Google on this and plug that in, say, okay, that many AU to kilometers, what is it? That is at minimum still over 50 million kilometers. So, really, really far away. Nowhere near the Earth or the Moon. And if you look at the close approach distances, for the next number of decades, it's still quite far away. Even in 2045, there's a predicted close approach. Now, there's some greater degree of uncertainty here. The uncertainty time for this month's close approach is less than a minute. See this right here, less than a minute. By 2045, the uncertainty is such that it's now over a day. It's 1 day, 8 hours, 10 minutes is what this means. So that tells you the orbit becomes uncertain by this point in time. At some point, give or take a day and change, it's going to have a close approach. And depending on exactly when that occurs, the distance could be anywhere from actually about 0.16 AU to 0.13 AU, but that's still a huge distance in space. If you convert that, that's over a tenth the distance to the sun. That's over 20 million kilometers. So, and that's not until 2045, but they're saying it's going to hit this month. It's going to hit in February. No, it's not. It's not even going to get within a third of an astronomical unit of Earth. So it's not all that close. The only reason it made the news, the only reason it's well known now is because it's got this odd orbit, which makes it look like a comet, but it's not outgassing like a comet. It doesn't have a coma. It doesn't have a tail. It doesn't have all the things we normally associate with comets. So chances are there's a good chance it's actually a dead comet. It's the remnants of a comet that have run out of volatile ices. So it's not outgassing anymore. But it's the chunk is still there, and it's not coming all that close to Earth. It's certainly not a danger to Earth. It's an absolute distraction and fake news garbage. But I think there was another one you mentioned, BS32, 2017 BS32.
That's correct.
Yeah, that one actually is interesting. It is a real near-Earth asteroid that flew by Earth earlier today, and I actually mentioned it in my webcast a couple nights ago. That it was going to fly by Earth and actually fly through Earth's shadow, which I think it did. The initial forecast was that it was going to fly through Earth's shadow at its closest approach. And there's actually a picture of it that a guy took with the iTelescope network Let's see here. Let me see if I can save this picture and move it on over here to drop canvas. So let me see here, drop canvas. I'm gonna upload this real quick because it's on a private Facebook group that I'm a part of. So full disclosure, I'm a scientific advisor for itelescope.net, which is a telescope rental service. You can rent telescope time online and collect your own images of these objects. And somebody actually did that with this 2017 BS32 image. Let's see here. Come on. Oh, my computer's being slow. Sorry, I gotta pull it up here again. Where is it? Where is it? I thought I saved it. Where is it? Okay, I saved it in the wrong directory. Sorry. 1 second. Okay, now it should be in the right directory. Come on. Come on. There it is. All right. So, yeah, here's a picture of this asteroid. Not a... Can you see this okay?
Yep.
Okay. So this little streak right here is the asteroid 2017 BS32. So, you know, somebody took this just earlier today as it was approaching Earth. And I'm not sure exactly what's causing this brightness variation. I don't think that was it passing through the Earth's shadow. That's probably actually from its rotation. It might be a fast rotating asteroid. I'm not sure. But yeah, it was a close approacher. So these things happen all the time. But, you know, 2017 BS32, it's a pretty small rock. It's not a very big object. So if we go to space weather, just as I wouldn't call this a primary reference, but just to get an idea, I think they, or not .org, sorry, it's .com. I think they usually list the size of these things, the estimated sizes at least. Yeah, 15 meters, you know, not that big. And it missed by 0.4 LD, 0.4 times the distance to the moon. You know, these things come up on us. And the thing is, current mandates for asteroid detection, it's kind of spooky. I mean, you want to talk about a real space threat. Here's a real space threat for you. So currently, there's a lot of asteroids that we're finding because there's a lot of asteroids we don't know about yet. And we're only able to find them when they come close to Earth because they're quite dim. They're really dim. And they're too dim for our telescopes to detect until they're basically right on top of us. So you want to catch these things, obviously, not on the orbit that they're going to hit you, but several orbits before so that you have time to actually do something about it. But the thing is, even NASA's current mandates, even if they had already completed their current mandate for what they're supposed to find, there would still be a huge amount of asteroids that could potentially devastate a city that we wouldn't know about. So here is, this is a chart showing the current mandated limit for what NASA's been directed to find. They're supposed to find now all these asteroids out to this limit according to, and I forget the name of the legislation, but it's like the NEO Detection something something Act, whatever it is, NEO Protection Act, whatever, trying to protect Earth from near Earth objects. And so this triangle here shows basically where they're supposed to get, what the asteroids they're supposed to find versus what they've actually found so far. So the green bars down here are the ones they found. The red line is the predicted population of asteroids. So it's all about a power law. We know that if we find, you know, this number of asteroids in this size, and we're not finding any more around this size or this size or this size, these big ones like the one that killed the dinosaurs, we pretty much know where virtually all those things are, at least in terms of asteroids, not comets now. Comets can, you know, come from the Oort cloud and give you a year warning at best. But in terms of asteroids around the asteroid belt, we pretty much know where these guys are, these really big global killers. The real threat is from these smaller ones, regional and city devastators. And we know that based on the number of asteroids in the larger size, the smaller the size, the more asteroids you find. And so we can extrapolate that out and say, okay, we think the total population size is something like this, but we've only found this many. And as you get smaller and smaller, we found less and less of them. And that means there's more and more of them that are still out there that we haven't found. And even if NASA completes its current mandates, that only fills in this triangle. You can see where these green bars are here. They're supposed to get up to here within the next number of years. But even once they do that, you still have all these asteroids out here in the city to small region size devastation that haven't been found yet. And that's, if you look at the actual sizes, that's everything below 100 meters. Even once they complete their current mandates, a 100-meter asteroid, something up to about that size, maybe a little larger, could sneak up on us at any time, and we'd have at best a couple days warning before it hit. If it were found on the orbit where it was going to impact, we'd have at best a couple days, possibly even hours. And that would be big enough to wipe a city off the map. If that hit downtown New York, if that hit downtown Tampa near me, no more downtown Tampa, no more downtown New York. And there would be very little time to get people out or warn anyone. And so that's where the real threat is. And, this is a very real space threat. And so it frustrates me when I see these other distractions like 2016 WF9. Okay, it's an interesting object, but it's not a threat to Earth. And yet we spend so much time having to address these fake news stories about this stuff when this should be the real news story. And unfortunately, where do you see that? You don't even see the tabloids talking about this. It's not sexy enough, I guess. It takes time to explain, so it doesn't make for a quick, punchy headline. But the headline, the real headline here, is that there are all these asteroids in this space on this chart that we think are out there. We're pretty darn sure they're out there based on what we know of asteroid populations. And yet we don't know where they are. They could be anywhere. They could be coming at us right now. We wouldn't know. And if they come at us from the direction where the sun is in the sky, we wouldn't get any warning at all. That's what happened in 2013 with the Chelyabinsk impact. It came from the same side of the sky that the sun's on. It came from the direction of the sun, and it hit Chelyabinsk and blew out a bunch of windows and injured people. And we had absolutely no warning. And we had no way of detecting that because it was coming at us from the direction of the sun. So one solution that's been proposed for this is to launch a spacecraft to monitor the region between the sun and Earth, looking specifically for asteroids, small asteroids, that could possibly do, this kind of devastation. I don't know if any's got funding yet, but I know there are some very real proposed missions out there on the drawing board that are supposed to potentially help us cover this. But that's what we need to be funding. That's what we need to be doing right now to prepare ourselves. Because if you don't know about it, you can't prepare for it. You can't protect yourself from it in any way.
Correct.
So that's the real space threat that's out there.
And it's unfortunate we're here trying to explain something that's already been said that's not going to be a threat to us. When, like you just said there, that chart really shows we've got all them unidentifieds that are a real concern. And that should be the headlines.
Yeah, it should.
Well, thank you very much for pointing that out.
Yep. So I think you wanted to ask about the stellar collision as well.
Yeah. Sorry, yeah. I've got two more topics for you.
Oh, okay.
And the next one is, as you say, is the stellar, the two stars, I do believe, which is KIC 983-2227. Now, there's an article in Sky Earth, which I'll just Google share. Give me a second. There we go. And can you see my screen?
No, I don't. Oh, there it comes. All right.
Yeah. And this is from Earth Sky. And it talks about that there could be a collision of two stars. And this is obviously, I don't know if this is the chords or the actual star names. And the theory is that they're going to collide in 2022. I don't know much about it myself, so obviously that's why I'm going to ask yourself, what do we know about this? Are they going to collide? If they do collide, what will we expect, and what impact will this have on Earth?
All right, so yeah, that is a real stellar collision that is thought to be coming in a few years. And so this is a star, the KIC designation, I believe, that refers, I could be wrong, I want to say that refers to the Kepler mission or something. Let's see, KIC. Kepler, yeah, that is the Kepler mission. So Kepler Input Catalog. So the Kepler mission was designed to look for transiting exoplanets, planets that pass in front of their parent stars and block a portion of the star's light for a period of time so we can detect them. And of course, it finds more than just that. And this is one object that's of interest here because it's what they call a contact binary, where two stars are swirling around so close to each other that they actually touch. And so here's an artist rendering of one of these things where you have almost like a single star, but it's really two stars that are merging together. And so basically, in a few years, it's predicted that these two stars will completely collide and potentially produce what they call a red nova. And so a previous example of this that people would probably be familiar with would be V838 Monocerotis, which is thought to be an example of a luminous red nova. And people probably remember seeing this picture from the Hubble Space Telescope. And this is pretty popular with Nibiru believers who claim that this is actually Nibiru. I've seen
I was
that
just going to
claimed
say,
before.
I've seen that photo on one of the fear-mongering channels.
Exactly, exactly. And so obviously this is, of a lot of interest to people, astronomers in particular, and we should keep an eye on it too, because if that happens and you get another picture looking like this, oh my goodness, can you imagine? It's going to be Nibiru heyday right there, with people saying, it's Nibiru, it's here, because it's actually going to, if this does happen, it could reach up to about magnitude 2. It'll be naked eye bright. Now, it won't look like this picture by eye. It'll just look like a star, but that's still a significantly bright star, significantly bright enough you can see it from fairly light-polluted locations even. So, they're predicting that somewhere between September 2021 and September 2022, somewhere in that time frame. So still a few years off, but it'll be here before you know it. I mean, heck, this is the year of the total solar eclipse here in the United States, and I thought this day would never come, or I thought this year would never come. I remember trying to get ready for it even as far back as 2012, starting to make plans of what I was going to do, thinking, well, I still got 5 years, it'll be a while. Now it's here, and now I'm like panicking because I got to make the plans quick because it's going to be upon us before you know it. So same story here. Just got to keep an eye on this and not forget about it, because when that happens, oh my goodness, it's going to be a Nibiru lover's dream, I guess. So one thing that we might be able to do to try to offset that and try to get the truth out about this would potentially be to perhaps do some photometry of it, of this eclipsing star before it collides, so that we can show data that says, look, this really was an eclipsing star. These really were two stars that were going around each other, and one would pass in front of the other and change the brightness of it. So I need to check and see what the brightness variation is of this system. I don't know off the top of my head just how dim it gets when one of these eclipses occurs, but the eclipsing binaries are pretty common things. Let's see, this little video should show it. Yeah, so this shows you what an eclipsing binary situation is like, where you have two stars passing in front of each other, but as one eclipses the other, the brightness dips a little bit. So when you have the two of them separated from each other, you can see both of their light, but when one blocks the other's light, obviously you can't see it. It produces this dip in the curve. And so the way you can detect these, you won't necessarily see them like this. You can't resolve them. They're too close together for the telescope to see this picture. This is just an artist rendering. But what the telescope can see is this dip in the light, which occurs on a very regular basis. And so if you measure the brightness of the star over time, you can produce a graph that looks like what you see at the bottom here, where over time it suddenly dips and then it comes back up, and then you get a smaller dip from the other one passing in front of the one behind. So you can plot that out and prove that it really is an eclipsing binary. And that shouldn't be too difficult here, as long as the dip is big enough to detect, because the period is only about 11 hours. So on any given night, it's very likely that you could see one of those dips from an eclipse occurring. So that might be fun to actually go after and target. And I can get it here in the Northern Hemisphere. It's at positive 46 degrees declination in the constellation Cygnus, which is the original search area for the Kepler mission. I forget exactly where, but somewhere in this constellation. Kepler basically spent 24 hours a day, 7 days a week, monitoring a set of stars in Cygnus for dips that might be caused by planets, or in this case, a dip caused by another star passing in front of in front of one of a pair of binaries. So that's the situation there. Kepler's now in a different sort of mode where it has to point at different locations in the sky due to some of the reaction wheels breaking down on it. It used wheels that spun, similar to what I was talking about before, how they use momentum, how spacecraft will use momentum to control their pointing direction. Unfortunately, with Kepler, its motors started wearing down, and so it doesn't have as much control over itself as it used to. So it has to sort of transition from different spots in the sky over the course of the year now. But originally, it was staring at this location 24 hours a day, all year long, which is how it was able to detect some of these things that we hadn't necessarily noticed before. So kind of cool. Looking forward to it because it'll be naked eye bright for people to see. And even now, like I said, if we get on it, we could potentially get some data on that. So Cygnus is a summer constellation. So hopefully in the summer I can get some data on that.
Yeah, I'll be looking forward to any videos that you do on this. Brilliant. Well, thank you very much for clearing that up. And I'm going to go to the last topic now, and then obviously I can let you go, and then you can enjoy the remainder of your night.
Thanks.
And the last topic is, well, it's a bit of a funny one to me, but we'll get your side of things and see how you translate this. But the topic is that Venus is a comet.
Oh boy.
Right, obviously I'll just do a screen share because I've managed to find a website that is talking about this. And the website I don't know much about, but it's redicecreations.com. And it goes on to talk about, you know, old Egyptian myths, etc., and you know, what they used to say, and the portraying, like I do believe, is it that Emmanuel, is it Velikovsky or whatever his name is?
Yeah, Velikovsky.
I do believe it's his theory too that comet, that Venus is a comet.
Yeah.
So my question to you is Venus a comet? If it is, you know, obviously, what's the history behind it? If it isn't, what is Venus?
Okay, so if Venus is a comet, then Mars must be a comet too. So this all comes from, well, I think a lot of it comes from the fact that Venus doesn't have a magnetosphere. It doesn't have a magnetic field. And so you get these interesting looking charts caused by the solar wind hitting the atmosphere of Venus. And so, like, let me pull one of these things up here just for comparison so we can see Venus solar wind chart. Okay. Yeah, like, in fact, I think they actually probably used this picture, the tail of Venus in the weak solar wind. Okay. I just want the picture, guys. Just give me the picture. Oh, for Pete's sake, I want the big version. All right, fine. I'll just pull up the whole link here so you guys can see it.
Well, whilst Astronomy Live trying to do that, if there's anybody in chat that has any sort of questions for Astronomy Live, write them down now. I'll check the comments and I'll ask you questions just before we tie everything up.
Yeah.
Okay, back to you, Astronomy Live.
Yeah, so this is where a lot of this sort of stuff comes from, I think. Talking about the ionosphere of Venus. As the solar wind hits it, obviously Venus has an effect of blocking that solar wind with its very thick atmosphere. And it affects the solar wind's magnetic field lines, all this stuff, and you end up with charts that look like this. And they say, oh my gosh, that looks like a comet. So it's a comet? No, that's not what a comet is. In fact, so you got, am I pulling up the right window here? Yeah, you can see this, right? Yeah. So let's see. No, I don't want that picture. Where's the other picture I had up here? Ah, this is a comet. This is Comet 67P, as imaged by the Rosetta spacecraft. And you can see all these jets of material coming off here from volatiles that are mostly situated below its surface, but sublimating out into space and creating all this dust and gas kicking off the comet and producing what we think of as a comet, a coma, a tail, all this stuff. Comets are relatively small compared to planets. They're measured in, tens of kilometers at best. And so they lack enough gravity to hold on to that atmosphere. They're mostly dust and ice. And by ice, I don't just mean water ice. I mean any given volatile ammonia ices, carbon monoxide ices, anything that can vaporize as it gets closer to the sun. And so as it sublimates off and carries dust and material away with it, you form the coma, you form the tail, in large part because the comet doesn't have enough gravity to hold on to that material. If it did, it would form its own little atmosphere, but it doesn't. It doesn't have enough gravity to hold on to it, so it just ejects off the comet and goes out into space. Well, Venus obviously is not a comet; it's a planet, and the solar wind will hit it, and the atmosphere will block that solar wind in various ways, and perhaps some of the atmosphere, some of the molecules from the atmosphere might get sheared off. But it's not the same situation as a comet, where it lacks sufficient gravity to hold on to anything, and it just ejects this stuff out into space. I mean, it's just apples and oranges. They're not the same at all. And so if you think that Venus is a comet simply because it has a tail due to the solar wind, then, well, I'm sorry, then pretty much all the planets are comets in their own way, I guess. But that's redefining the word comet from what astronomers would know the word to mean. So the MAVEN mission was sent to Mars to study how Mars is losing its atmosphere. And so Mars, just like Venus, lacks a significant magnetic field, and its atmosphere is getting stripped away, and it has its own sort of model of atmospheric loss as a result of this. And, if you look at this chart, the same people would probably tell you that means Mars is a comet, I guess, but I haven't really heard that claim made, since a lot of these charts came out more recently with the MAVEN mission. So if you Google MAVEN Mars atmospheric loss, you'll come up with all kinds of cool-looking charts that I guess some would say are proof that Mars is a comet. Because, oh yeah, here we go. Here's another good one. So this is actually really cool, because this one shows. Oh wait, no, I don't want the full website. I just want the big nice picture I just had a second ago. Oh, come back here. Okay, let's just view image here. This is a big image. I'll give it a second, but this shows a nice comparison between the situation with Earth and the situation with a planet like Mars, which lacks a magnetic field. So Earth has a magnetic field, obviously, which protects our atmosphere from solar radiation, from the solar wind. And so our atmosphere doesn't get stripped away like Mars's does. Mars, for whatever reason, for reasons we're still trying to understand, its magnetic field that it probably had earlier in its life shut down. And it doesn't have the kind of geological activity Earth has. It doesn't have the magnetic field Earth has. And its atmosphere is getting stripped away. Earth's magnetic field protects our atmosphere from the solar wind. And so we have a magnetotail. It pushes our magnetic field back. And in that way, Earth has its own tail. It's not a tail of particles. It's a tail of its magnetic field. But Mars doesn't have such a thing. And so the atmosphere is just hit directly by that solar wind. But, I don't know. I mean, maybe as a result of this webcast, you're going to have people now putting up videos with these photos saying, look, Mars is a comet. Oh, my God. Well, okay, then I guess we have to redefine what planet and comet are, but that's not what they are. So there we go.
Well, thank you very much for clearing that up. And I'll just check to see if there's any questions in the comments. And has there anybody got a question for Astronomy Live whilst he's here? If not, I do believe then we can wrap things up. Once again, for all you that are watching or you that watch the rerun, I would urge you all to go over to view Astronomy Live's channel. It's got a wealth of videos, of obviously live telescope events, the detail in his videos in discussing certain topics is second to none. And like I say, he's a very friendly, down-to-earth guy, like I said in past videos. Whenever he's doing a live hangout of his telescope broadcasts, he'll always be the first to try and answer any questions that you've got. And I've got a lot of respect for this gentleman, so thank you, Astronomy Live, as I said, for taking this time out to do this for me. I do believe there's no questions. So with that said, Thank you very much, Astronomy Live.
Well, thank you very much for having me on. It's been a pleasure, and I hope people will check out my channel. And if you're interested, subscribe. And I'll be doing videos very shortly about the upcoming SDO eclipse season, as well as other astronomical events that are going on. So these last couple of asteroids, they haven't happened to pass in such a way that they're visible from my location here in Florida at their closest approach. But when that sort of thing happens, I do like to set up the telescope and track those asteroids too. So if you hear about an asteroid in the news, if it's visible from here, I'll try to track it for you guys and show you some live images of that as well. So whether you want to, want some astronomical videos for the debunking, or you want them just to see current events, I try to provide a mix of both. So thanks very much for having me on, and it's been a pleasure.
No, thank you very much. As I say, yeah, please subscribe to Astronomy Live and continue to support the truth work that we're providing. Thank you very much. Take care.
Yep.